Hello! As you know, I'm a chem major, so today I'm going to show you a Diels-Alder reaction. To start, here are the starting materials. The first is eucalyptus oil. The main ingredient is alpha-phalandrine, and this will be our main reactant. This is its chemical structure. It is known as the conjugated diene. This means that it has two double bonds separated by one single bond. The other reactant is maleic anhydride. Here's its structure. It is known as the dienophile. As the name implies, this means that it loves the diene. So here's the Diels-Alder mechanism with these two starting materials. The electrons from this double bond attack there, and then those electrons from that double bond attack there, and then those electrons form a new double bond there. The product from this reaction is shown here, and the two new single bonds and the new double bond are shown in black. Now, let's start the reaction. Yay! First, safety. So rubber gloves and safety goggles must be worn. First, I'm dissolving the maleic anhydride in the eucalyptus oil. The water condenser makes any escaping gas cool and drop back into solution. Here it is in reflux, which basically means it's dripping. Now, time to let it cool down. This is the vacuum filter to remove all the extra stuff from the crystals. Now it's time to purify. Here, I'm adding petroleum ether to dissolve the crystals. And now the solution is cooling again. This allows the crystals to reform. Then into the ice bath, along with some more petroleum ether. Back into the vacuum filter. Here, I'm adding even more petroleum ether to cleanse the crystals more. And here is the final product. Aren't the crystals so pretty? By the way, it's apparently really hard to film white reflective crystals. I promise they looked better in real life. After letting the crystals dry overnight, I came back to the lab the next day to take a few measurements for the experiment. First, I took a mass of the crystals. Now, I already took the mass of the empty watch glass yesterday, so the actual mass of the crystals is 1.463 grams. Now to find the melting point. First, I have to pack the crystals into this little capillary tube. Then, I had to drop it down this tube a few times to compact the crystals in the bottom. Here is the melting point device. This is the temperature readout, and over here is where the product goes into the machine. The thing jiggling inside is the tube, and the white part on the bottom is the product. This device heats up the product gradually and gives the temperature. Melting point isn't an exact number, it's a range. It is measured from the temperature where the first drop forms to the temperature where the entire product is liquid. While my melting point was a little off due to impurities, the actual melting point for this product is 126 to 127 degrees Celsius. And now I have to dispose of the product by putting it in a properly labeled container. So that was a day in the life of a chemistry student. What'd you guys think? Don't forget to like and subscribe, and to watch Emily's video tomorrow. Bye!